Welcome back, guys. Today we're going to look at one important part of the Java language, which is the DateTime API. We know that the DateTime API was added, or we can say it was improved in JDK 8, and it came with a whole lot of utility classes that are very useful when you're dealing with DateTime objects. So we are going to look at the following under this DateTime API lecture. So the first thing, as I've mentioned, is that the new DateTime API was introduced in JDK 8, and we saw that it was put in a package called Java.time. So all other packages are sub-packages of these packages. And the reason for this new DateTime API, it was to address the problems of the old date classes that were put in java.util. So what is it that you find in this new Date API that you think that we can say it's really important? The first thing we see is the design of it. I mean, these classes are designed with ISO 8601 in mind. That means they are coded with standardization in mind, because this ISO 86, if we can just do a quick Google search, you will see that it's actually an international standard covering the worldwide exchange and communication of date and time-related data. See that it was first published in 88 and updates were done in 1991, and then we see these are the times until 2022. So the new DateTime is actually ISO 8601, which means it's actually following the standard. And also we see that in those classes we have a lot of useful methods that actually does the work for us. We don't need to do quite a lot of things as you used to do with the previous DateTime objects. And one other important thing is that these classes are thread safe, which makes them quite usable when you're also in multi-threaded environment. And lastly, we see that we have ability to deal with different time zones when you are using these new DateTime objects. Like, you're able to say, I want the time in the US as of now, with much ease, without you having to do a lot of work in your code. You just give it the time zone that you want, and it will give you time from that particular area. So this DateTime that was added in Java 8 is really important. Then what are the packages? We have java.time, java.time.temporal, java.time.format, java.time.zone, java.time.chrono. The java.time is the main API for dates, time, instance, and duration. As you can see, all others, they actually branch from it. And mostly the classes defined in that represent the principal time concepts: instant, durations, date time, time zones, and periods. And they are based on ISO calendar system, which is the de facto world calendar following the proleptic Gregorian rules. And all the classes are immutable and thread safe. So inside the branch of it, which is the temporal package, we have the classes there, or what you call whatever enums or interfaces that are used to access date time fields and units. Then you have format, which is used to format input and output of datetime objects. And then the zone ones actually handles time zones. Then we have the chrono, which supports calendar systems such as Japanese and Thailand. And the classes, mostly you will be working with LocalDate, LocalTime, LocalDateTime, instant, period, duration, zoned date time, ZoneOffSet, ZoneId. So what is a local date? A local date is a date without time zone in the ISO 86 calendar system, such as you see there 2007, December the 3rd. A local date is immutable datetime object that represents date, often viewed as year, month, day. Other date fields such as day of the year, day of the week, and week of the year can also be accessed. For example, the value 30 December 2002 can be stored in the local date. However, it is important to note that the class does not store or represent time or time zone. Instead, it is a description of the date as used for birthdays. It cannot represent an instant on the timeline without additional information such as offset or time zone. So the ISO 86 calendar system is a modern civil calendar system used today in most of the world. Then we also have the local time, which is a time without a time zone in the ISO 16 calendar. And as with the local date, local time is immutable and represent time, often viewed as hour, minute, and second. And then time is represented to nanosecond precision. For example, the value 13 hours 45 minutes 30 seconds, and the others is nanoseconds, can be stored in a local time. So this class also does not store or represent time zone. Instead, it's a description of a local time as seen on a wall clock. It cannot represent an instant of a timeline without additional information such as offset or time zone. Then we have local date time, which is actually a date time without time zone in the ISO calendar. So basically it's a combination of local date and local time. So this class is also immutable and it represents date time, and we normally view it as year, month, day, hour, minute, second. And other date and time fields such as day of the year, day of the week, year of a week can also be accessed. Time is represented to nanosecond precision as well in this case. For instance, the value 2nd October 2007 at 1 p.m. 45 minutes, 30 seconds, and nanoseconds can be stored. And also, as with the others, it does not represent a time zone. It's just a description of a date as used for birthdays, combined with local time as seen on the wall clock. It cannot represent an instant on the timeline without additional information such as an offset or time zone. So the methods that you'll normally find inside local date, local time, and local date time are the off, now, from, past, exact, and these are mostly what you will be working with. And these methods, some of them are overloaded, as we'll see when we do the coding. Then we have what we call the instant. This is actually an instantaneous point on the timeline. It's a machine time from epoch. Internally, it uses a long variable to hold a number of seconds since the start of epoch. And we know that epoch started in the 1st of January 1970. So it uses to store a number of nanoseconds elapsed for each second, and used to record timestamps also. If you want a time at a specific, let's say you want to store a time when a transaction occurred, this is what you can use as it's a timestamp. Then we also have zoned date time. So it's a date time with a time zone. Remember, the previous ones didn't include any zone. So it's a date time with the time zone in the ISO 8601 calendar system, such as 2007 December the 3rd. Then we see there we have 10:10 Europe, Paris. So the zone time is an immutable representation of the time with a time zone. This class stores all date and time fields to a precision of nanoseconds, and a time zone with a zone offset used to handle unambiguous local date times. For example, the value 2nd October at 1:45, and we see there the offset is +2. In the Europe, Paris time zone can be stored in the zone date time. And then this class handles conversion from local timeline of local date time to the instant timeline of an instant. The difference between the two timelines is the offset from UTC Greenwich, represented by the zone offset. So the zone offset is a time zone offset from Greenwich UTC, such as 0200. So what is that 0200? It's a time zone offset, and is the amount of time that the time zone differs from the Greenwich UTC. This is usually a fixed number of hours and minutes. So the different parts of the world have different time zone offsets. The rules for how offsets vary by place and time of year are captured in ZoneId class. For example, Paris is 1 hour ahead of Greenwich UTC in winter and 2 hours ahead in summer. So the ZoneId instance of Paris will reference two offset instances, a +01 hour instance for winter and a +02 hour instance for summer. So in 2008, the time zone offsets around the world extended from 12 hours, -12 hours to +14 hours to prevent any problems with that range being extended, yet still provide a validation. The range of offsets is restricted to -18 hours to +18 inclusive. Then we have ZoneId, a time zone ID such as Europe, Paris. It's a zone ID. So a zone ID is used to identify the rules used to convert between an instant and a local date time. So ZoneId.system default will give you the current system zone, and ZoneId.available get available zone ID will give you all the zone IDs stored that comes with the JDK. And there are two distinct types of IDs. The first is the fixed offset, a fully resolved offset from UTC Greenwich that uses the same offset for all local date times. Then we have geographical regions, an area where a specific set of rules for finding the offset from UTC Greenwich apply. Then we also have what you call time units. Time units, we have temporal unit. The temporal unit interface is part of the temporal Java time temporal package, and it represents data time units from years, months, days, hours, minutes, and seconds. And the implementation of this interface represent implementation of those interface represent those units. So if I can just search for that. We see here we get duration and all those things that we require here, and we can get one of its implementation, which is this one. As you can see, nanos, micros, millis, and blah blah blah, and all that. That is why here it says implementations of this interface represent those units. It's because the chrono actually shows us the units that we actually are talking about. We see here we even have eras, forever, millennia, period of 1,000 years, centuries, period of 100 years, decades, periods of 10 years, years, months, and all that. We find them inside the chrono unit. And this was added in Java 8, as we did mention in our lecture. So we already saw that the chrono unit is an enum that implements temporal unit, and we saw from our previous lectures on advanced classes that an enum can implement an interface, because an enum is implicitly a final class. So we see that chrono unit, as we saw, it's a standard set of date periods units. It implements temporal unit. We saw that we have century, era, we have year, month, and the others. Then we have DateTime formatting. So dates and times often must be printed in different formats. Also, date and time information may be given in different formats. So use of DateTime format class is quite important for that, and we find that inside the java.time.format package. So there are two distinct types. There are distinct types that you can use for formatting. We see that we have ISO date, which will show this kind of format, 2015-11-01. Then we have ISO time, which will give you this particular format. Then we have RFC 112 date time, which will give you this kind of format. Then we have ISO zone date time, which will give you this kind of format. So we have a couple of formattings that we can do. We will see that when we are coding this DateTime API. Then the format style also, we see we have full, which actually can be Saturday, June 21st, 2022. Then we have long. This is the example that we have June 21, 2022, medium, November 11, 2022. We see that this one, the month was cut. Then we have short, which will just give you the dates in numbers separated with the slashes. Then we have what we call period, which is a date-based amount of time in the ISO 8601 calendar system, such as 2 years, 3 months, and 2 days. This class models a quantity or amount of time in terms of years, months, and date. The supported units of a period are years, months, and days. All three fields are always present, but may be set to 0. So if we say period of 2 weeks returns P 14 days. And then if we say period of months 1, it will be P 1 month. Period of years 2, it will be P 2 years. And then we say period past, and then we say P 1 year, 2 months, 10 days. It will return it as 1 year, 2 months, 10 days, just like this. Then we have duration. Duration is a time-based amount of time, such as 34.5 seconds. This class models a quantity of amount of time in terms of seconds and nanoseconds. It can be accessed using other duration-based units, such as minutes and hours. It is suitable for measuring machine time or when working with instant objects. For instance, if we say we have duration of 3,600 minutes, As we can see, it amounts to 60 hours. And then if we say we have duration of days 4, we will get 96 hours. And duration of hours 4, we have PT 4 hours. We have duration of minutes 5, we have PT 5 minutes. Duration of seconds 3, we have PT 30 seconds. Observe the difference. The first one we only have P, the second one is PT. T stands in for duration time. So thank you guys. The next lecture we are going to do the coding now.